Hello, everybody. Welcome to the third in a series of Git and GitHub workshops. While we're waiting for everyone to join us, it would be lovely to know where you are in the world. I'm in the UK, just outside London, in a town called Tunbridge Wells, Royal Tunbridge Wells, in fact. So for anyone who doesn't know me, my name is Claire, and I'm one of the TAs at Launch School. I'm also a student, and I'm just over halfway through the Ruby track. So if you'd like to share your location, put it in the chat, but no pressure, you don't have to. So a couple of people from the US, Chicago and Michigan. Welcome. Got anybody from Europe there? Asia, Africa? New York City. Oh, someone from India. Wow. Isn't that from Italy? I've got a friend living in Rome at the moment. I wonder whereabouts in Italy you are. Someone else from Nigeria. Great. Florence. Okay, I think that's north of the country, is it? North of Rome. My geography is not great. Centre. Okay. North of Rome then. Okay, so in the previous two workshops, we looked at Git and GitHub. Today, we're going to learn more about Git. Don't worry if you weren't here in the last sessions. These sessions are standalone, so you'll be able to follow along. One word of note is that this is a 90-minute workshop because we're going to have a lot of fun. The usual 60 minutes in the past hasn't given quite enough time for me to explain things calmly and to give opportunities for questions and to answer them. So we've extended this to 90 minutes so I can still fit in all the same content and not have to cut it down. There are some tricky concepts to go through in this workshop. So if you do have any questions as we go along, put them in the Q&A, and that's where I'll keep an eye on what's going on. I don't keep an eye on the chat so much, but the Q&A I do, so put something in there. If it's something that isn't related to what I'm currently talking about, I'll answer it at the end. But if it's something that we're doing right now, then I'll try to address the question straight away. Then there'll be time at the end for further questions as well. I'll also post a link to a feedback form, and I'm going to put that in the chat now. So anyone that needs to hop off early, you can grab that form and fill it in, please. It's really helpful. Let us know what's working, what's not working. We've made quite a few changes, some feedback that I've got before. So I'm really grateful if you could fill it in, please. If you want to code along, please go ahead. Don't worry if it doesn't work for you, because I'll be using multiple choice quizzes throughout, so it'll be interactive. I'm working in AWS Cloud9, which you can see on the left of my screen. Now, we recommend this environment because it's all set up and you just code on a website. It's nice and easy. But if you've got an environment that you prefer, then use that. You don't have to use Cloud9. So let's have a look at what we're going to cover today. I'll do a quick overview of Git to remind us about that. Then we'll look at what branching is, creating a branch and then merging them. And then the last two things are going to be about undoing things. So undoing changes to files and files that you staged. And then the last thing is amending recent commits. So if you commit some files and they go, that's not right, we'll look at how we can change that. So just a quick recap, Git is the tool we use on our computers to track changes to code files. We do it by creating Git repositories. And then within those repositories, information is stored to keep records of the history of the project. So what changes have made them, who made them, and when they were made. In order to see the real power of Git, we're going to play around with an existing repository. So the first thing to do is to get that repo. So let's have a quick overview of Git. All on one screen. So a bit of theory. Git tracks changes to files using three conceptual areas: a working directory, staging area, and the Git repository. The working directory is where our code files are stored, and that's where we're making changes to them. The staging area can be thought of as like a waiting room. And once we've made changes to a file in the working directory, we can save those changes to the staging area. And then when we've staged all the changes to various files that relate to a particular update, we then commit those changes and they get saved in the Git repository. Now, at first glance, the utility of the staging area is not always obvious, but when we come to undoing staging and committing later on, we'll see that it can be useful. because if we're making changes to the code base that relate to different bits of functionality, the staging area enables us to commit those changes separately, so they're in separate commits. So they can be logically grouped and have descriptions that are relevant to them. And the staging area enables you to do that. So in the student notes, you can see the commands used to create a Git repo and to move the changes to the files through each of those areas. So git init creates the repo, then git add will save changes that you've made in the working directory to the staging area, and then git commit saves the changes from the staging area into the Git repo. And then the last three commands are all about viewing information about the Git repository. So git status tells us what is currently going on. So whether there are changes to the code that we've not staged or not committed. Git log gives us a history of the repository. So it lists all of the previous commits, who made them, when they were made, and the description of them. And then lastly, git diff. This displays differences in the files between the working directory and the staging area. So all three of those commands we're going to use a lot today. Now, don't worry about memorizing the commands. I'll explain them as we use them. And the more you use Git, the more these will become second nature. Now, the scenario we're going to work through today is that we want to develop a cipher decoder. And we've heard that Bletchley Park is a great code breaker repository that we can adapt to decode ciphers. And luckily, they've made that repository freely available to anyone to download from GitHub. So GitHub is a website that provides a friendly user interface for sharing Git repositories. And by downloading a repository from GitHub, we can ensure that we are all starting with the same baseline. So we can all be working on the same repository. And then after we've downloaded it, we're going to be working locally. And so we're not going to care anymore about GitHub. And in fact, you don't need a GitHub account. You won't even need to go on to GitHub, because I'm going to give you the link for it. So we're purely using GitHub because I've created like a dummy repo on there that we can download. And so we can all be working on the same thing. So if you are coding along, even if you don't have a GitHub account, you can clone the repository like I'm going to do. So I'm just going to put a link in the chat window. And if you click on that link, you can copy the command and then paste it into your command line. And the only thing you need to make sure is that you're not already in a Git repository. You'll know if you're in a Git repository because after the command line prompt, it will say something like main or master. If you're somewhere where you've got that, you just need to navigate up until it no longer says that, because it's bad practice to nest Git repositories. You don't want to put a Git repository inside another Git repository. So if you get that code from the link I've just shared, it will look like this. So we've got Git because we're working with Git. Clone because we want to create a copy of this repository on GitHub. There's then a URL, so the address for where that repo is stored. And then the last argument, cipher decoder, is just going to create a folder where we are now, where it's going to put this repository into. I don't provide that last argument. It will just create a folder called Codebreaker. It will use the same name that GitHub uses, but you don't have to. And I've decided not to, so that's why I've provided that last argument. So if I do that, I can then see if I go to the file tree, it created this folder here. Inside it, I've got all of the code files here, and then .git, that's where Git stores all of the information about when changes have been made, who made them, and what they were, things like that. Okay, so, and my prompt goes a bit squiffy because I'm zoomed in, so you're going to see me do this a lot. Just want to clear the screen. So let's just navigate into the folder we've created. I'm in here, so now I can see I'm in a Git repo because I've got main in brackets in the prompt. And if I do, a little bit bigger so the command doesn't split over line. If I do git log, this is going to show you all of the commits to this repo. Now, this dummy repo that I created, I only did one commit because I'm a bit lazy. So that's why there's only one commit recorded. So we've got the commit, and then we've got this hexadecimal here, the hash, which is a unique identifier for each commit. We've got that I made that change. There's my email address, and then when I made it, and then the message that I put in there, the description of this particular change. So what we can see is that we've got the history of the repository as well as the code files. So let's now learn about branching. So what is branching? So a branch is a copy of all the files in your code base. When we create a branch, it's sometimes referred to as forking, and each branch has an identifying name and its own commit history. So when you create a new branch, it will copy the history of the branch that you branched from, and have its own branch. So they'll be identical up until that point, and then they'll split. Now, when a new repository is created, the primary branch is called main, or master if you've not changed it from the Git default, but main is preferred because that's what GitHub expects. So it should be called main. And if you don't create any additional branches, all Git commands you execute will be performed on this branch called main. So why would you want to create these additional branches? Now, branching enables developers to veer off into experimental directions without affecting the primary code base. So you might use branching when you're developing a new feature that's going to result in changes to lots of different parts of the code base. You're not sure if it's going to work out. So if you create a branch and it all goes pear-shaped, you can just kill the branch, go back to main, and everything will be as you left it before you branched off. So to create a branch, we form one from another existing branch, usually main, and then we switch to the new branch that contains all the commits in the main branch up to the point at which we forked off. They're now copied across to our new branch, and then we can add some new commits. If we're successful, we can then merge those commits in the experimental branch back into the main branch, and then delete the experimental branch to tidy up. And it's as if we never created that branch and we just worked on main all the way through. But the advantage is if the branch was unsuccessful and it didn't work, we just vaporize that branch and go back to main and just carry on working there as if nothing happened. And so it's a way to experiment without having to undo things that you've changed. One thing to note before we go any further is that only the committed versions of files are forked and merged. So any changes that are in the working directory or staging area that haven't been committed will not be included when you create a branch or when you merge the branch. So you just need to make sure that your code base doesn't have any unstaged or uncommitted changes before you branch or merge, and you'll see me do that repeatedly. So back to our scenario, we've thought of a really exciting change we'd like to make to the Cypher decoder repository. But we think it's best to create a branch so we don't muck anything up that we achieved so far. So that's what we're going to do now. We're going to create a branch. So to create a branch, we fork it from another existing branch. And as I said previously, you can only fork from commits, not the working directory, not from staged files. So in this case, we're going to do it from main because we've not created any other branches. And in fact, I only ever branch from main. My experiments work and I merge it back in, or they don't work. I just delete them and carry on with main. So first of all, we're just going to check that there aren't any other branches lurking about. So we do that by just doing git branch. If I make this smaller. So just do git branch, and this lists all of the branches. There's only main, so that's the only one that's listed. If we do git status, you'll see me do this a lot. It says on branch main, the brain is up to date with origin main, nothing to commit working tree clean. That's the key thing we want to hear here. Nothing to commit working tree clean. So there aren't any changes we've made to the working directory, the staging area that haven't been committed. And that's what we want before we create a branch. So now we know that, we're going to create the branch. So to create a branch, you do git branch, and then you past the name of the branch you want to create. So I'm just going to call it super algorithm, because I just like giving myself the challenge of typing algorithm 100 times. So git branch super algorithm. So that has created the branch. So if I now do, I'm just going to clear the screen, it's got a bit cluttered. If I now do git branch, you'll see there's 2 branches listed. Now I've got main and super algorithm. The asterisk, and that it's in green, tells us that we're currently in main, as does the prompt. That tells us that we're in main as well. If we want to switch to the branch, we do git switch and then the name of the branch. That moves us there. So we can see the prompt has changed. We've now got super algorithm in our prompt here. And if I do git branch, we've still got the 2 branches listed, but now the asterisk is next to super algorithm. If we look at git status, we'll see the same thing that we did before, nothing to commit, working tree clean. It also tells us that we're on branch super algorithm. So that's another way to tell where you are. If we have a look at git log, this shows us that we've got all the history that we had in the main branch. So it's all copied across, that we only have that one commit, and that one commit is still there. If we, so there is, someone's asked this question actually, which I've got here. So git switch is a relatively new command. It was introduced in 2019. Prior to that, you needed to use the command git checkout. So instead of doing git branch super algorithm, you do git checkout super algorithm. Now, if you look at older sources of information, you're likely to see git checkout rather than git switch. Either command is fine to use. Git checkout still works, but git switch is a command that only changes the branch that you're on, whereas git checkout can be used to do other things as well. That was confusing, and so git switch was introduced as a command to do just that one thing. And another thing, so we created the branch and moved to it. So we did git branch and then the name, and then git switch and the name to create it and then move to it. You can do that all in one go. So you don't need to do this because we did it in 2 stages. But if you do git switch and pass the C flag, and then the new branch name, that will create the branch and move you to it all in one step. And the equivalent of that for git checkout was with a B flag, like that. So you can use git checkout, that's totally fine. I prefer to use git switch because, as I said, git switch is purely about switching between branches, and you can't do anything else with that command. So it's just easier to understand what's going on. So now we're in this branch, we can do everything that we could do on the main branch. So we can make changes to the working directory, we can stage changes, commit the changes, all without affecting the files in the main branch. That stays as it was when we branched off from it. All the files that I now open up in the file tree over here, they're all on the super algorithm branch. So if I want to make a change to, say, the README file, just double click to open that up. So I've already got something in there. I'm just going to add some text at the bottom. You can type it or just add whatever you like. This will include a super. Okay. So I've just added a line to the bottom of the README file. If I just save that change and go back to the command line, I'm going to type clear because this has gone very squiffy. We're going to use git diff to check that that is the change that we wanted to make. So if I do git diff, this shows me the changes that I've made. This is what I was expecting. it's only, I've only made changes to the README file. I haven't made changes to any other file. And this is telling me what was in that file. And the green lines are telling me what I've added. If I'd taken something away, it would be in red. I added a new line, and I added this will include a super algorithm. So this is just telling me what I added. And so I look at that before I stage my change to just check that the changes I've made are what I think I've done, and they are here. So now I can just do git add dot. I could do git add readme to just move the changes in the readme file from the working directory into the staging area, but I'm a bit lazy, and dot just moves all the changes to all of the files in the working directory to the staging area. In this case, I've only made them to the readme, so they'd be the same, but dot is quicker than readme. And now the changes in the staging area, I'm going to commit it. So I do git commit, pass the M flag, and then a description of the change. So I'll just do added super algorithm like that. Yeah, that tells me one file was changed, 2 insertions, a blank line, and a line of text. And we can keep going with this, making changes, staging, committing them. All the while, our main branch remains as it was when we left it by forking off this branch that we're working on now. So before we move on to merging branches, let's have a quick quiz on the new commands we've learned about branching. Now, these quizzes are just for fun. I can't see what anyone's answering. It's not recorded anywhere, so don't have any fear. They're just for fun, and just keep it all a bit interactive. So give it a go. I'll give you a couple of minutes. Oh, and I need to take the answers away. I don't want any cheating. Okay, I'll just give you another 20 seconds or so. Let me know if I'm not giving you long enough for the quizzes, and I'll extend it. I don't want people sitting twiddling their thumbs either. Okay, I can't actually see any more answers coming in, so let's end the poll there and then share the results. And then I can bring up the answers. Okay, so first question, to move to the bug fix branch when it's already been created, you use git switch bug fix. For the second question, to create a new branch called bug fix without moving to it, you do git branch bug fix. And then to create the bug fix branch and move to it, everyone got that one right, you do git switch the mine with the C flag and then bug fix to do both of those things in one go. Okay, so I've got a question. I'm just going to see. Console says end on Twitter. Okay, Kendra, it's hard for me to help someone whose screen I can't see, but try and press Q. That might quit you out of where you are. Okay, so merging branches. Yeah. So we're happy with all the changes that we've made to the branch, and now we want to include them in the main project. So let's just, I only did one commit, but let's make believe that I did several. And So while we were on our new branch and we made all these changes, lots of commits, in the meantime, someone else could have been working on the main branch, or indeed another branch, and then merged it into main and made changes. So the code in the main branch that we merge our super algorithm branch into could be different from the code it was when we forked to create the new branch. This is where Git comes in. Git is clever. It will merge the changes together. And if there are any conflicts arising from the changes that have been made, Git will warn us, and it will suggest how they can be resolved before the branches are merged. It's beyond what we're covering today. There'll be no conflicts for us because we have branched off from main. We're making changes to the new branch and then merging back in. So main won't have changed. There will be no conflicts, and that's how I normally work. But I just wanted to mention that when you start working with other people, that is where Git really comes in, because it identifies where your code might conflict and how to fix it. So while I'm working on a branch, I tend to leave main alone and just work on that branch, and then either merge it back in, vaporize it, go back to main, and just carry on. So to merge the changes in the new branch into our main branch, you first have to go back to the main branch. This is a really important step, and I can't tell you the number of times this is not working, and it's because I was trying to merge the branch I was on with the branch I was on. So if we have a look, let's clear the screen. If I do git log, we can now see there are 2 commits, and they're ordered chronologically. So the most recent one is at the top. And from my previous workshop, I'm still Dorothy rather than Claire. Anyway, so this also shows where they diverged, because we can see super algorithm is at the top here, and main is down here in the bottom one. Now, the text in red origin is referring to the GitHub repository. So it's telling us that the GitHub repository is down here in this one, as is the main branch, but the super algorithm one is up here. And then this head tells us where we are. So the code files, when we open up code files in our file tree, the head is telling us that this is where they'll be opened up from. So we're in the super algorithm branch. That is where we are. So by doing that, I've messed up the prompt. So if I just do clear again. So as I said, we need to make sure that you switch back to main, because you have to pull the changes onto where you are. So I'm going to do git switch and then the name of the branch I want to move to. So it's main. And I've spelled switch wrong. There we go. So I've switched to the main branch. And then I can just double check where I am. I can see that I'm in main here. And then if I do git branch, again, we'll have main and super algorithm listed. Main's got the asterisks. That's where I am. And if I do git log here, we can see now that I've only got 1 commit here. So the main branch has no knowledge of the commit that was made on the super algorithm branch. And we can see head, we're now down here in this commit, it's pointing at main. So when we open up these files in our file tree here, it will be on this main branch. Now, here we could delete the new branch and it would have no effect on the main branch. So don't do this, because this is more we want to do, but I want to show you. So let's just clear the screen. And the command is git branch, then the name, then the flag, which is a capital D, and then the name of the branch. Just take an M off there, just in case I accidentally pressed enter. Okay, so git branch with a capital D flag, and then the name of the branch will delete the branch that you're not on anymore and that you don't want to merge in. So be careful, because when you do that, you're going to lose everything on that branch. So if it wasn't rubbish, don't do this. But we're not going to do that, because we're happy with the changes that we made. So instead, we're going to bring the changes from that branch into main. So to do that, we do git merge, and then the name of the branch we want to merge. So git merge, and then the name of the branch that we want to merge into where we are. So if we do that, it tells us one file change, 2 insertions. So it's quite a similar comment that you get from when you create a commit. The fast forward is referring to there are different ways to merge things, which we're not going to cover here. This is just telling us that we've just brought the main pointer forward up here. You don't need to know anything other than that, but just if you're wondering what fast forward means, it's the type of merge that we've done, and it's the default type. As long as you don't change main when you're playing around with a branch, you won't get merge conflicts anyway when working on your own. So this will always be fine. And if we do git log here, we can now see we've got these 2 commits here, and we can see that main and super algorithm are both up here at the most recent commit. Now, to keep things nice and tidy, let's delete that branch. So if we do git branch, we pass the lower D flag and then the name of the branch. If we did that before we'd merged it, Git would say, you haven't merged it yet. If you really want to delete a branch that you haven't merged, you need to pass the capital D flag. So that's why you can use the lower D one when you have merged. Okay, so now it's deleted. So now if I do git branch, you can see main super algorithm has gone. All of the changes that we made in that branch have now been merged onto main. So let's have a quiz on the commands we've learned about merging. Come off of here first. I'm learning. So let's launch this one, give it a go. Okay, I'll just give you another 10 seconds or so. Still a couple of answers coming in. So I can't see whose answers are coming in. I can just see that some answers are coming in. Okay, let's have a look at the answers. So to delete the bug fix branch when the branch hasn't been merged, use git branch with a capital D, bug fix. And then for the second question, to delete the bug fix branch after it's been merged, you can use git branch with a lower D, bug fix. And I've got a question coming in saying, what happens if you use that lower D command without merging first? Git will give you a warning. It will say you can't delete that branch. You've not merged it yet. If you want to delete it, you need to use the capital D flag. It's really helpful, actually, as we'll see. It gives you feedback when you do the wrong thing, which I like. It's really helpful. So answered that live. And then question 3, to merge the bug fix branch with the current branch, you do git merge bug fix. Excellent. Well done, everybody. So we've learned how to use branching for developing experimental features for our code. So you just create the branch, work on it. If it works, go back to main, merge it in. If it doesn't, go back to main and delete it. That's all there is to it. We just made one commit, but you can make as many commits as you like, keep going. And you can even create branches off of those branches again. So if you're doing something experimental off of experimental, you might want to go off and create another branch and play around with that. And then if it works, come back, merge it in, carry on, and then come back, merge it in. I mean, I only ever create one branch because I just work in baby steps. So I never do anything that complicated. Right, so let's now learn how to undo changes to our code base and the Git repository when we inevitably make mistakes. So I've got it all on there. So we're going to go through the workflow of making changes to the Git repository. But at each stage of this workflow, we're going to undo the changes so we can learn what to do if we make a mistake at every point. And we're going to do this on the main branch, but all of this applies to working on any other branch as well. I'm just on main. I've got rid of that branch that I created. I've only got main, so we're going to do it on main. So first of all, let's make a change to the README file. I'm not going to say this, right. I'm just going to add some more text at the bottom here. So you can write anything you like if you're coding along. LS students and adaptation to Cypher. Okay, so I've just added a line at the bottom. Make sure I save the file. I go back to the command line here. Do git diff. This shows me the change that I've made. So I've only made a change to the README file. I added an empty line and then that line of text. It's kind of a little bit confusing when you see this, but the more you look at it, the more you hone in on the bits that you need to look at. And the important thing is there aren't any red lines. I haven't deleted anything, and the green lines are what I would expect them to be. So if I now do git status, widen this out again. Right now, right. This has got lots of useful information. I'm just going to clear that and then do git status again. Okay, so it tells us we're on the main branch, good. And it tells us that we're ahead of origin main, so we're ahead of the one on GitHub by one commit. We're not worried about that, so we're not worried about GitHub today. But it helpfully tells us to use git push if you want to push your local commits. Like I say, Git has all this useful information. It then says changes that are not staged for commit. So it's telling us that we've made changes to the README file and we haven't staged those changes yet. It also tells us how to discard those changes using the git restore file. So it tells us to use git add if we want to stage the changes, or git restore on the file name to discard the changes. Now, the git restore command makes a file in the working directory match the version that was last staged. Now, I haven't staged the file that I've changed since the last commit. So in this case, it's actually going to take me back to the last committed version. But if I had made changes, staged them, made changes, staged them, made changes, and then gone, oh, I want to undo those changes in the working directory. If I use git restore, it will just take me back to the last staged version, not the last committed version. That's quite useful because if I'm staging stuff, I should be pretty happy with it. So if I just want to take it back to the last staged version, which here is also the last committed version, we do git restore and then the file name, README. We do git restore README. And then if I open up the file, you can see that change I put in has gone. And if I do git status here, again, we no longer have this red file name saying, oh, you've made some changes that you've not staged, because that change has now gone. So we're all back to where we were before we'd made those changes. Now, if you have made lots of changes to the working directory, you've staged some of those changes, and you just got into an almighty mess, and you just want to get back to the last version of the files that were committed, luckily there's a command for that, and it is git reset hard. Okay, git reset hard. Now, be sure you want to do that, because you will lose all of the changes in your working directory and the staging area. You'll just go back to the last committed version of all of the files. So it isn't quite a severe command. There's no going back from it, but sometimes you do just get into a right mess, and this is how to get yourself out of it. And when you're working with Git, ideally, you're making small incremental changes to your code base. So as soon as you've got something that's working, you should stage and commit those files. So if you do need to do git reset hard, you shouldn't really be losing hours and hours and hours and days of work, because you should be committing fairly regularly. So maybe it's not quite as harsh as it sounds. Anyway, we're not doing that. So we're going to go back to here and make another change. So let's make this different text just so we can, since an adaptation to break cipher codes. Okay, so I've added another line, just going to save that change, go back to the terminal. So I'm going to do, going to clear the screen, and then I'm going to do git diff. So you can see here, again, we've got the change that we wanted. We've added a new line, and we've added that sentence. So we're happy with this. So because we're happy, we could just do git add dot. So now I've staged the file. And then I realized, oh no, actually that wasn't quite right. So if I look at the status of the repo now, README isn't red because I have staged the file. It's green because I've not yet committed it. And again, it tells us use git restore with the staged flag and the file name to unstage the file. It's actually telling us what to do. So if I don't want to use git reset hard here because I've made changes to other files and they're all fine. So I don't want to go back to the last commit. I just want to undo that last thing. I just go, oh, I wish I hadn't done git add dot. I just want to unstage that README file. So I do git restore with the staged flag and then the name of the file, which I need to spell correctly. Git restore with the staged flag and then README. So if I do that, that gets us back to as if we'd never staged the file. And I can see that. I'm just going to clear the screen. If I do git status, we go back and it's now in red. So it's as if I never staged that file. If you had made changes to a number of files in the working directory and staged all those changes and gone, oh no, I want to undo all of that staging, you can do git restore staged without a file name, and it will unstage all of the files. Whereas previously we'd named which one we wanted to, but if we just want to unstage all of them, because we did git add dot, and actually we didn't want to do that, then git restore staged is how you get out of it. So actually it's all fine. So if we go back to README, we can see that that unstaging didn't change the working directory. That change I made is still in the working directory. It just took it out of the staging area. So I've looked at that and it's still all fine. This can be particularly useful actually if you've made changes to multiple files and then you stage them all, but you realize that the changes to the files don't logically fit with one another, they're sort of functionally different things, then you might want to unstage one of the files, go ahead and commit the other one, and then stage the file that you unstaged and then commit that one. And then those two files that you would have had to have committed together, you can actually put in separate commits with separate messages. So that's why unstaging can be useful. As I said before, if you've muddled up your changes and actually they don't belong together, this is how to uncouple them. So actually the file is fine. I'm happy with the change that I made. You know, I look at git diff and yeah, I'm happy, that's all fine. It's what I was expecting. I'm going to stage the file. So I do git add. That's great. And now I'm going to commit that change. So I do git commit and then just add a description there, functionality. So I've got git commit with the M flag and then the description of the commit that I'm going to do. So enter. So it says one file change, two insertions. So it was the README file that was changed. And I did a blank line and a line of text. So I'm going to clear the screen now. So if I do git status, it should tell me that everything is up to date, working tree clean. Great. And you know, this is just showing me that there are no files that have been changed in the working directory compared to the most recent commit. There's nothing in the staging area that hasn't been committed. So this is all up to date. So we've undone changes in the working directory and we've undone changes in the staging area. And the next section, we're going to look at undoing changes to commits. So let's have a quiz on undoing changes in the working directory and staging area before we move on to undoing things to the commits. So give this a go. Okay, I'll give you another 10 seconds or so. Okay, let's have a look at the answers. Okay. Okay, so to undo changes in the working directory since the most recent staged version of the specified file, use git restore and then the file name. The second question, to remove changes from the staging area since the most recent commit for a specified file, you do git restore the staged flag and then the file name. And then if you just want to undo all changes in the working directory and staging area since the most recent commit, just do git reset hard, just vaporize it all, just go back. So if it was all a bad nightmare, and just start again. It's a useful command, but use it wisely. Okay, so we're now going to look at amending the most recent commit. So we're having a really bad day and we've realized there's a problem with the commit we just made. Now, a note of warning here, don't mess with previous commits. If you push them to GitHub, it just messes up the log of commits. And if you shared your commit with anyone else, don't change it. Changing commits that other people are using will make you really, really unpopular shit. So just don't do it. In this case, we haven't shared our commit with anyone else. We've not pushed it to GitHub. So we can carry on mucking around with this most recent commit, but just be careful when you do this in the real world. There are 3 ways that we can change the most recent commit. We can change the message, we can add additional changes, or we can just undo it altogether. And we're going to go through each of those in turn. So first of all, I do git log and go. I've now got the 3 changes that I've made. And from this, I can see that I made a mistake in this message here. I didn't mean it to say cipher breaker functionality. So to change that message, I do git commit and I pass the amend flag. So git commit and then amend. So when I do that, this opens up quite a scary looking editor. It looks scary to me. This is just nano, but actually along the bottom, it tells me what I need to do in order to save things and get out of things. So I just want to change this to, oh, that didn't work, to maybe cipher breaker functions. I'm just going to make a small change there. Here it says, oops, it says write out. So I just need to do Control and O, and it says file name to write. Don't worry about file name, just press enter. And then, oops, and then I do Control X to then exit out of here. So if I now do git log, I'll be able to see that the description of that last commit has changed. So do git commit amend, it takes you into an editor, you make the changes in there, and then when you come back out, the change will be reflected in the git log. Now git commit amend can also be used to add changes that I forgot to include in the commit. So these changes might be in the working directory. So maybe I just forgot to save the file before staging it, or maybe I just forgot to stage the file completely. So either way, I can fix that. So if I go, I'm going to make a change to a different file. So if I open up license instead, and I'm just going to add a line, like this is licensed for use. Score. Okay, so I've just added a line there and save it, and I've done this in the license file. Let's clear the screen. So if I use git diff, you see it again, just added an empty line. And I think I meant to change that. And show you deletion. I'm going to do that because I just like to be thorough. So I'm going to delete that line and replace it with something else instead. Okay, so there was a line there saying this is licensed for public use, and I've changed it to this is licensed for use by LS. So now if I do a git diff, I'm able to show you what a red line looks like. So when most of this line is the same, this is licensed for, I've just changed the end of it. But the way that Git handles changes to lines is it's just treats it as if the whole line was deleted and a whole new line was added. So I've got a red line saying this is licensed for public use, that was removed, and then this is licensed for use by LS is what was added in. So I'm going to use, so that's all okay. And now I'm going to use git add and then the file name to stage the file. Now we could have gone straight to this point if I'd made changes and just forgotten to stage the file rather than make the changes or save the changes. If I'd just forgotten to stage it, then I will just go straight to this point and just stage the file that I forgot to do before. And then if I do git status, this will tell me here that I've got this file that I've staged and I've not committed. And I use the same command that I did before to amend the most recent commit. So I've got git commit amend. Again, it opens up this text editor. Now, I can change the message again if I want to, but actually I don't want to. All I want is to have that file license included in this commit, which it wasn't before. And I can see that it is included in this commit now. So all I need to do is exit out of this text editor with Control X. And if I now do git, how can I see the change? If I do git status, we can now see there's nothing to commit, working tree clean. So that change that I made in license has now been incorporated into the previous commit. I've still only got 3 commits. I didn't create a 4th commit. It was just incorporated into this one here. So git commit amend, you can use to add additional changes to the commit, and you can also use it to change the message that you used. The last way to change the most recent commit is just to undo it altogether. And the command for that is git reset head. So this will undo the last commit. There'll be no changes in the staging area, but all the changes you made in the working directory will still be there. It will be as if you didn't stage and commit the files you most recently committed. So if we do this, if I look at these files, I've still got the changes in there. But if I do git status, oops, both the files are red. So it's as if I never staged and committed the files. So git reset head, it just undid that commit as if I never staged anything from the last commit and never did the commit. And if we do git log, we'll see that most recent commit is gone. So we've only got 2 commits now. Now, again, be careful undoing commits. It's fine when you're working on your own, not muck around it, just go for it, it's fine. It's only when you start working with other people that you need to be careful about this. So be careful what habits that you're getting into. You really, if you're regularly undoing commits, you need to think about your workflow, because you really shouldn't be committing stuff unless you're sure that it works. I've got a question here saying, can you get a list of the committed files? Only as far as doing git commit amend. That will tell you for the most recent commit what files were in there. So Yeah, so that previous, if we exit out of here, so we can see I thought this was how you did it, but this is telling us changes to be committed readme, changes not stage 4 commit modified. Okay, I'm going to say I don't know the answer to this question. Can you get a list of the committed files? I don't know. Ignore what I was doing here. Shouldn't have gone off piece. Okay, so where was I? Okay, so yes, so you can undo a commit. It won't get rid of the changes in the working directory, but we looked at that before in the previous section. Git reset hard will take you back to the previous commit. And this is just unstatical. And this is just behaving as if you hadn't staged those changes and you hadn't committed them. If we now do a git diff, we'll be able to see that there are changes to these two different files. So we've got changes to the license file first, that we removed that line, added this line, and then we've got the changes to the README file where we just added one line. So we didn't lose those changes, even though we did uncommit them, unstage them. And so if we assume it's all a bad dream, actually the files are fine. We do git add and then git commit cipher functions added, and then git log. We've now got those 3 commits in there. Okay, do I need to say this again? Don't mess around with the most recent commit if you've already shared it with other developers. Changing commits other people have already started using. It's just not the way to make friends. Just don't do it. Don't even think about it. Okay, so we're going to have a quiz now on amending commits. So I'll just clear this and start launch this poll. There's only 2 questions in this one, so give it a go. Okay, so let's end that poll and then have a look at the answers. Don't forget, if you need to hop off early, please fill in the feedback form. So there were just 2 here. So if you want to undo the most recent commit, do git reset head tilde. And if you want to change the commit message or add additional changes to the most recent commit, you do git commit with the amend flag. Now, that is all for today. But someone is having a problem with making those changes when you do git commit amend. And so it may be that your system is set up to open the Vim text editor rather than Nano. And I'm on a Mac, so that's what happens to me as well. Don't go into Vim very often. And it, unlike Nano, it doesn't have like that helpful bit at the bottom giving you instructions as to how to do stuff. So just Google it. It's nothing to be afraid of. Just Google how to make changes with Vim, and it's something to do with colons. I think you do colon Q to quit out of stuff, and colon I to insert, and then escape to get out of insert mode. Maybe you just press I to insert and then escape to get out of insert mode. But anyway, you know, when you're learning, this is the time to be playing around. This is the time to not be afraid of what you're doing. Just have a go. There's always people out there in launch school to help you if you do get into a role model. The Slack forums are really helpful. The general forum people help out, but then there's also the prep channel, and then there's a channel for each of the courses as well. So do reach out on those if you get stuck. Okay, so let's have a look at what we did today. No, I'm going to have to make this small, I'm sorry. Or maybe I should just leave it on 2 pages. So here we go. So first of all, we did a quick overview of Git, and we then looked at branching, creating a branch, and then merging a branch, or just deleting a branch without merging it. And then we looked at undoing changes. And then we did amending the recent commit, either changing the message, adding new changes, or undoing it completely. It feels like we've done a lot. And maybe it does when I list these commands, but actually I don't think there are that many commands there, given all of the things that we've seen to do. And you don't need to memorize these. All you need to do is know that they exist. So then you can look them up and learn how to use them. All the information is in Launch School's Git and GitHub book. And then there's also, if you type in Git help and then the name of the command that you want help with, you also get information here as well. And it can be a little bit cryptic, but the more you use the help documentation, the more you will get to understand the vernacular that it's using and stuff. So the information is there as well. It's not that cryptic, is it? I mean, it does tell you. Just be aware that it can refer to the staging area as the index. But I think it often tells you that it's doing that. Like the command can be used to restore the content in the index with staged, or restore both the working tree and the index with staged and work tree. So I think, you know, my message here is just not to, and you just press Q to get out of that, is not to worry about playing around with things. So I've got one last quiz, and it's only 5:10 where I am, so I've got loads of time. So if you've got any questions, please put them in the Q&A and I'll get to them. And I'm going to give you one last quiz to summarize everything we've learned. So I said you don't need to memorize all of those commands, but you do to do well in this quiz. Okay, so good luck. Okay, I'll just give you another 10 seconds or so. Stephanie, when you say, can you provide the link for a Slack channel, do you mean like the specific Slack channel or just how to get onto Slack? Because I can't provide information on how to get into Slack, and that is all in Launch School's prep stuff. And then when you're in Launch School's the specific Slack channel, right? So okay, it is hash prep course questions. Prep course questions, that is the place where beginners start. So that is the place if you're a little bit shy and you know, scared about asking silly questions, which you shouldn't be, because if you think it, somebody else thought it. That's the channel to go in and ask those questions, and people will spend their time helping you. It's great. There's also another one for people starting out with AWS Cloud9. So if you're having things that are specific to the Cloud9 environment, then that's a good place to help. Now, once you are on your own environment, like you're on your own Mac and stuff, it's much harder to help people because everyone's system is just set up slightly differently. And it's just one of those things, being a software developer, environment configurations is just a bit of a nightmare, really. And using Cloud9 kind of circumvents that because you're on a standard environment there. It's not linked to your computer, it's out on the cloud. So if you are unsure, I do recommend using Cloud9 to begin with because there's much more support available. So Stephanie's asked if you need to be a paid student of Launch School. No, you don't need to be a paid student of Launch School to access our Slack channels. There's one channel that is for paid students only called Student Lounge. And there's a bit of an in-joke there because once you pay Launch School, you cannot get out of that channel. So other channels you can exit so that they don't appear in your feed all the time. But the Student Lounge one, you just get put back in. It's like Hotel California. You can check out, but you can never leave. But that's the only channel that you can't access as a non-paying. Still too many negatives in there. That is the only channel that you have to pay a subscription in order to access. All of the others, you don't need a subscription. Right. So let's end that poll and look at the answers. So for question 1, Git merge branch name, that merges the current branch with the named branch. Then the Git branch name, that just creates a new branch. Excuse me, Git switch branch name, that moves you to the branch. So you use that instead of checkout. Git reset hard, that will undo all the changes to all files in the working directory and the staging area since the last commit. So it'll be like you hadn't done anything since the last commit. Git restore staged file name, that removes the changes to that file from only the staging area. So any changes in the working directory will still be there. Git commit amend, that enables you to make changes to the most recent commit. And then git reset head, that undoes the most recent commit. So again, it's as if you hadn't made that commit, so you hadn't staged the files, and you hadn't committed them. Excellent. So now I've got a question about what is the difference between stage and stash. So if you've made some changes to some code files and you just, I don't really think that's right, I'm just not really sure, you can do git stash, and it puts them over to a stack somewhere. I never do this, so I'm guessing a little bit here. It stashes them somewhere, and so you can so undoes those changes in your working directory, but you don't lose them entirely, and so you can carry on working. And then if you want them back, there are commands you can use to get those changes back. So it's not at all the same as staging, because staging is getting it into the repository. Eventually you stage it and then commit it, whereas Git stash is sort of putting it to the side, and it's not going into the commit. If it's been stashed, it's not going into the commit. You need to stage it in order to get it into the commit. So I hope that explains it. It's not something I use, and it's beyond the scope of what I'm covering today, but I can understand the confusion because it is something that people do talk about. So are there any other questions? If not, I'm just going to post the feedback form. I can add some more content to this. I've still got another 14 minutes. Yeah, if there's anything else that you think should be added to this workshop, then the feedback form is your opportunity to do that. If you think this just isn't long enough and Claire just needs to cover more Git stuff, the feedback form is where you can have your say. Conversely, if you think this was too long and too much information, then again, you might want to fill in the feedback form and let us know that as well. So thank you all for great participation in the quizzes. So I hope that was really helpful. And lots of interesting questions as well. I just get to expand out of what I'm saying, so it's really helpful. And yeah, please fill in the feedback form. And if you missed any of the workshops, we'll be going around, we're doing them all again. So if you missed my first my GitHub one, and you've now seen how brilliantly I explain everything and you need a bit of help with those early ones, then I will be running those and we'll put the dates out for those soon. So enjoy the rest of your day. I'm going to enjoy the rest of my evening. Take care.